This is my physics report for Lab 3. So an introduction and objectives to this lab. The purpose was to measure and observe how the magnetic field differs with distance. And I did this both on and off axis of a magnet using a magnetometer on my phone, and I compared these findings with that of a computational model. And I found that the magnetic field increases as you get closer to the barred magnet, and the overall and the dipole moment I found to be 1.97. And then the key concepts for this lab is mainly the Biot-Savart law, which states it relates the magnetic field to the distance between the source of the field and the observation point. And the magnetic field for a dipole axis is this equation right here, and the magnetic field for a bar magnet is this. And we will combine these later to find the magnetic dipole moment, mu, in the equation if the magnetic field and distance measurements are taken, which I do in the procedure. So for the experiment, I first had to compensate for the magnetic north by rotating my phone until the x component is 0, which basically means the magnetic north is all in the y component, so that I can isolate the magnetic field that my phone picks up due to the bar magnet only. And I measured this magnetic field at a distance that is dperp until the x component of the field reads 5 different measurements: 20, 70, 120, 170, and 220 Teslas. And then I moved the phone off axis, as you can see in this diagram, at the x location where the field is 100 microteslas. These are supposed to be microteslas, sorry. And I record the y component of Earth's magnetic field, move the phone the same distance, this distance up, and then record the x and y components and correct the measurement based on the y component of Earth's magnetic field to do some calculations, which I'll get into later. But this is a screenshot of my Excel data. Now you can see the different measurements here, the distances, and then the magnetic field at those, and then the off-axis measurements as well. And this is the graph of this data. And I use this equation: the natural log of the field is this, and the slope is natural log of r, y-intercept natural log of k, or n is the slope, sorry. Yes. And then I found, and r is the dependent variable in that previous slide. And then I equated the magnetic field with the dipole bar magnet, which I talked about earlier. And K was found using the previous slide, natural log of K's y-intercept. Corrected the mag field by subtracting Earth's mag field from the measured y component of the mag field when it was off axis. And then I could do this to find the data I found in the introduction. And then I compared this with a computational model. This is a few excerpts from my code. This is based on the general magnetic field equation, and this is used to calculate the magnetic field of the bar magnet. These two are used to draw the arrows, which you'll see in the next slide, of the magnetic field of the bar magnet, which is a visualization of what my phone was picking up, which is pretty cool. And this is just more code regarding the distance that my phone picked up. And these are the results. As you can see, these blue arrows and orange arrows, the orange arrows are on axis, the blue are off. They're all perpendicular. They're in different directions, indicating the flow of the magnetic field from south to north here in circles like this. And these are the measurements that the model found, which are similar to mine. So discussion, possible sources of error could be the external magnetic fields distorting the measurements, such as nearby devices, the surface not being completely flat, which could mess with the magnitude of X and Y components, as well as the magnetometer itself not being accurate due to being an iPhone app. So what if I didn't orient the phone to compensate for the magnetic north? Well, the X and Y components would be affected. The magnetic north would affect X component when the phone is on axis, and there would be a Y component on axis, which can't be due to the bar magnet, and this would distort what I'm picking up, and my measurements will be inaccurate. However, the Z component would still be unchanged because the table is supposedly completely flat. And then what if I stuck two identical magnets together and did the experiment again? Well, the field would increase, hopefully to about double the original experiment. The distances would decrease, but the general qualitative observations would remain the same, such as that the magnetic field increases as you get closer to the bar magnet, and the directions will be the same as well. Thank you.